those back out and open to page 184. And complete number 1 on page 184. Yep. And then we'll talk about it. Trace, what did I tell you to do? On page. Okay, got it done? Right. So just do the best that you can on number 1. We'll talk about it. Alright, what do we notice about the number sentences in problem number 1? What do we notice? Jaden.
That 5 can't go into some of the numbers.
Okay, so 5 can't go into some of the numbers. Okay. Anything else you notice? Bethany?
Multiplication.
Okay, multiplication. Yep. Good. What's on one side of the number sentence in every single problem? Ethan.
It's like 5
Yep.
times a fraction.
Okay. Yep. So 5 times a fraction and then it's 5 on the other side, right? Yep. So how do we know whether the product will be greater or less than 5? So, Miranda, letter A, less than, greater than, or equal to?
Less than.
Less than, how did you know that?
Well, I did 5 times 1/2, and that was 5 halves, and I made it simpler to 2 and 1/2, and that was less than 5.
Good. So she took 5 times 1/2 and knew that was 5 halves, and then she simplified that into a mixed number and got 2.5, right? Yep. Okay, letter B. Addison,
Greater than.
how did you know the product had to be greater than?
Because I took 5 times 2, and that was 10, and then I put 5, I did 3, and then it has like a 1.
Okay. Okay. Letter C. Letter C. What do we got? Shane? Shane? Greater than? And why did you say it was greater than? Okay. Okay, good. Letter D. What do we have for letter D? Addison. Greater than? Why did you say it was greater than? So it's less than. Why is it less than?
Because 86, 87
Okay, good. And the last one. Bethany. Equal to, how'd you know that?
Because 5 times 1 is 5, and the other one's 5.
Okay, so the ones that are, now look at the ones that you have that are greater than, and look at the ones that you have them that are less than. What do you notice? What do you notice about it being greater or less than compared to the fraction that it's being multiplied? Do we notice anything? So look at Addison, what do you got?
It's only greater than if the fraction is more than 1.
Good. It's only greater than if the fraction that we multiplied 5 by is greater than 1. That would make sense, right? Because we're multiplying a greater than 1 fraction times 5. So it would make it more than 5. So then if our fraction that we're taking times 5 is less than 1, it's probably going to be less than, right? Because it's less than 1. So a number less than 1 times 5 is going to be less than 5. Because we know 5 times 1 is 5. Good. All right. So, you can go ahead and close those for now. And then you can get your math notebooks out. Yep, you guys can copy this in your notebooks. All right. We are going to fill in these blank spots with fractions that are equal to 1. So what are some fractions that are equal to 1? Lila? 3 thirds. Lily? 5 fifths. Dallas? 10 tenths. Tyler?
2 halves.
Okay. 2 halves.
I know another one.
Madeline?
4
4 fourths. Okay. What do you guys notice about these fractions? Erica? Yep. It has the same number as a numerator and same number as a denominator. Now, we had learned how fractions relate to division and a couple days ago when we were working on that. So how do we know that all of these equal 1, talking about fraction and division? Erica? Good. So we know that, like, we'll take 3 thirds, for example. 3 thirds is the same or equal to 3 divided by 3, because our fractions are just division. So if we have 3 divided by 3, we know it's 1, right? Okay, so we're gonna solve some multiplication here. So and you can copy these in your notebooks. Can you see these? Okay, now help me answer these, because we know how to multiply fractions now. We know an easy way to multiply fractions. Dallas, what's 2/3 times 4/4? 8/12. 1/3 times 5/5. Addison. 5/15. 3/6 times 2/2. Shane. 6/12. Okay. Now, what did we notice about our first fractions and our answers, or our products? What did we notice? What did we notice? Jaden.
They're all common denominators.
Well, we found a common denominator, yeah, but what did we know about these two fractions? 2/3 and 8/12. What are they? Miranda. They're equivalent, right? Because in all of these, we took them times the same numerator and the same denominator, right? So then these, our answers, are equivalent fractions to our first fraction. Yes? Yes? All right, good. All right, so now we're going to do something with a visual here. Okay, so I'll erase this so we have some more room. Okay, I'm going to draw two visuals on the board here. I'm going to draw a visual for 2/3, and I'm going to draw a visual for 2/3 times 4/4. Okay? So draw this in your math notebook. Okay, so get these drawn. Okay, now look at my two drawings up here. Are they shaded? Are they shaded the same? On both visuals, is the same amount shaded in both? But this one has more pieces. Ethan.
No, they're the same because the lines going vertically is 2/3.
Okay, so you're saying they're shaded the same because you looked at your vertical lines. So that one had two vertical lines shaded, this one has two vertical lines shaded. Okay? Shane.
They're the same because if that was like a tray of brownies, then you could cut them that just like that.
Yep.
And then if you wanted to after, you could cut the vertical lines going this way and it'd still be the same amount.
Okay, so these are the same. You guys have to determine that these are shaded the same. Now, what is 2/3 times 4/4? Lily? 8/12. What did we say about this fraction and this fraction? Miranda? They're equivalent.
They're equal.
So therefore, the two visuals are the same amount as shaded on both visuals, right? Because this is an equivalent fraction to this. Okay, we're going to do one more. All right, we got 3/4 and 5/5. 3/4 and 3/4 times 5/5. Okay, are these two boxes shaded the same? Chase? Yes, they are shaded the same. Why?
Because you didn't do the 5/5 on the 3/4.
Okay, so if these visuals are the same, what does that suggest about these two fractions? Ethan? That they're equivalent, or they're the same. Okay, so we had our 3/4, and we had our 3/4 times our 5/5, but they're the same because we still have 3 parts colored in here and 3 parts colored in here. So that suggests that, like Chase said, that suggests that 15/20 is an equivalent fraction to our 3/4. So, you need to understand 3 points from today's lesson. Okay, the 3 points, I'll write them up here. Okay, so our 3 points from today's lesson. What are they called? Okay, so this is point number 1. The multiplicative identity property tells us that the product of any number and 1 is that number. What would be an example of that? What would be an example of that? Ethan. But what's an example? So give me. Okay, but we're talking about the product of any number and 1. So it'd be 2/3 times what? Times 1. So an example of this would be like 2/3 times 1 is 2/3. So this property tells us that the product of any number, so 2/3 is our any number, times 1 is that number. Okay, our second point. Okay, our second one. When a number is multiplied by a fraction equivalent to 1, the product is equivalent to that number. So what would be an example of this? When a number is multiplied by a fraction equivalent to 1, the product is equivalent to that number. Ethan. Okay, so 2/3 times 3/3 is 6/9. So 6/9 is equivalent to 2/3 because 3/3 is the same as 1. And that's like the list of ones that we went over. Okay, one last rule. I'll write it over here. Oops. Okay, and our last rule. Can my people see it over here? Multiplying by a fraction equivalent to 1 is the same as multiplying by 1. So what's an example of that? Multiplying by a fraction equivalent to 1 is the same as multiplying by 1. How do we know that? What's an example of a fraction equivalent to 1? Miranda. 2/2. So if we take 2 times 2/2, it's the same as taking 2 times 1. They're the exact same. They're equal to each other because 2/2 is equal to 1. Yes? We get it? Yep. Alright. You can leave your math notebooks open to help you if you need help. You guys are going to finish the rest of page 184 in your math journals. Just individually. Yep. Just individually.